All right. So over to you, Prashant. I've started the recording.
It started. Okay. So yeah, let me just share my screen. Let me know once you guys can see my screen.
Yeah, it's visible.
Okay. Yeah, so I can, should we start or we should start, right?
Yeah, we can start.
Okay. Yeah, so hello everyone. I'll start with my introduction, a short introduction. So I'm Prashant Kalkar. I have around now almost 15 plus years of experience. And I've worked on roles like almost all the roles, to be honest. So right from the development till the ops side, architecture side, and all those things. Okay. So yeah, it's a fortunate thing that I can work on all those technologies. And then around that, there are lots of learnings as we do and as we work on those. So this is my attempt to essentially share those learnings around the infrastructure as code. And mainly, this talk is mainly around the things that I have seen. Generally, people get it wrong. Okay, so that's what I've tried to capture as part of this talk. Okay, so you can see my screen and hear me fine, right? I will just
Yes.
start the presentation. Okay, so the way I have organized this talk is into essentially two sections, two primary sections. One is around the evolution of the tools and the practices around infrastructure as code, and the other one is around how the code practices are there and what should we follow around it. So code structure and how do you manage the infrastructure code base. So all those things. So we will talk about that. So first section is mainly around the tools. Okay. So let's start with it. Okay. So evolution of the infrastructure practices and tools. So the first question, actually, to be honest, is why do we even need to know the past? Okay. And what's the point of actually understanding the evolution? We can look at the current state and learn from the current state, but why do we want to also see how the things has changed over a period of time? And the thing for that is to essentially understand why the newer tools or practices are coming up and what they are actually bringing in. What are they solving a new problem, or is the problem changed? So that understanding actually tells you a lot around things, and then it also tells you that are you doing anything wrong. Okay, so we will look at some of these tools. Okay, this also tells you that what is the right tool for the right job, which one, at least how to think about these things. Okay, then in certain places what happens is the previously good practice or the norms basically get completely changed because of the change in the context. Okay, and because of that you should actually try to understand what is really changed, how the context is changed, and then why you end up with the new practices, why you end up with new tools, and how what they do, what do they really bring uh, along with them. So before we start, I want to actually define a term called configuration management. Okay, so configuration management, when I'm going to use that in this presentation, is basically I'm essentially talking about configuring a server. Okay, it can be a physical server or it can be a virtual machine. Okay, but whatever we are doing in terms of installation of softwares on those machines, okay, or we are doing some configuration at the OS level. Okay, So all those things is basically configuration management. Okay, that's what I'm going to use that term throughout the talk. So what essentially saying is any OS changes, then any installation of application runtimes. So let's say you need to install Java, JDK, or anything like that, or you need to install Python runtime to basically run the Python based projects and all those things is all part of the config. Anything that you do inside a VM or a machine is basically configuration management. So this will also include, so if you are running things like any supporting application like RabbitMQ or MongoDB or Prometheus on either VMs or the actual machines, what you are essentially when you install them on the machines, you are essentially doing configuration management. Okay, so that's how I'm going to use that term throughout the talk. Okay. So let's talk about things that are there before even the cloud comes in. Okay, before there was a cloud being used by the organizations. Organizations almost need to essentially own the infrastructure. They need to buy physical servers and maintain them themselves. Not every organization need to do that. There were certain companies that essentially were managing this infrastructure for you. Okay, but it is still at the end of the day someone having physical infrastructure and setting up for you, and you essentially have access to that, and it's a fixed set of machines that are maintained for either for you by some other company, or you yourself is managing that. So your company itself owns the hardware. Okay, so that's how it is before the cloud. And the way in, so let's see how the practices were around this. So very at the very start of the things, when you have like small number of machines, not too many things going on, all you need to do is manage everything manually, and you can essentially live with that for few days, or as long as you have like manageable things around there. But quickly things becomes difficult because of two things. One is the scaling, and another is the other issues around doing the changes manually. Okay, so if you are maintaining anything or doing anything manually, this is a high risk thing. There is always a possibility that you might do things differently the next time, and then you end up with like completely different setup or completely different configuration on one machine. Okay, and then the one machine doesn't really match the other machine at all, and then it works on one of them, it doesn't work on the other, and then you essentially have the issue of why it is working here and not there. What is the exact difference in these machines? uh, and the thing is, if you do things kind of manually, then you have to repeat that every time. You have to, so even if you have a documentation or some readme or something like that, which gives you the list of commands to essentially follow, you are essentially doing that manually again and again. Okay, and every time you do that, if you skip something, if you take a different decision at any point of time, you try to become smart, you say that, oh, this command is really not required, because I tried that last time, it was not required, so I'm going to skip it. So if you do something like that, you essentially are configuring the machine in a different way now, and then it doesn't match. And if you do that between the environments, then your environments are not matching. So it might not fail immediately. That is actually a worse part. If it fails immediately, that's a good part. Okay, but if it doesn't fail immediately, then what happens? So over a period of time, these machines are like now are completely different. And because of that, it might fail in future. So something that works in, let's say, dev or UAT will not work in the next environments. And then it will be a big headache for you, because you were hoping that you will essentially get these failures in the earlier environments. But if you get it in production, that's like a big issue. Then, yeah, so different servers will look completely differently because they are changed at different times. So all those issues are there. So one of the things that you can do is the reduce the manual effect of it, and then you say that instead of me following, let's say, a README or something, I already have the set of things I need to do. Why can't I use something like a script? Okay, so the first attempt is essentially you say that I will use a script, and because it's a script, I can reuse it again and again in different environments and different machines, and that's how I end up with exactly the same thing. So this might work for some few things, but again the challenge will come in is that, so when you are using a script, what the script essentially need to do is it need to understand the current state of the server, and then it needs to understand the current state and then move it to a desired state. Okay, so it need to apply or carry out certain commands to essentially move that current state to the desired state. Okay, that's what this script is essentially doing. So it is completely imperative. You decide which steps need to be taken. Now the issue with this is if your current state is different, okay, that means your steps to be taken to the desired state will also be different. Okay, so that means that becomes an issue to essentially you might not be able to use the exact script that you used in some other server because the state of that server was different and the state of the new server is different. The current state is different. And then you now need to figure out that how do I actually go to the desired state? What is already there? What is not already there? And how do I essentially do that? So current state matters in a script, and it's an imperative thing. So you need to know that which steps I need to take to actually go to the desired state. Okay. One of the things that you can do in script like that is if you need to figure out that do I actually take this step or not take this step, is to create steps like that are idempotent. So the step itself figures out whether it needs to do it or not. So for example, if I'm saying, let's say install Java or something like that, then you essentially say that instead of just installing Java blindly, you essentially have an intelligence in your script says that, is there a Java already installed? And if it is already there, then I will skip that step. So all those things you can do. There are still issues around if I remove a step, then that doesn't correspond to actually removing Java from the infrastructure. Okay, because that step is removed, but it is still in the earlier execution that package is already installed, and then it doesn't really lead in terms of removing that thing from the service. So all those things are there, and there is a possibility of gap between your automation and the resultant state of the service. Now, the other thing that happens is it is very difficult to actually say or talk about the resultant state of the machine. So I cannot say that these are the things are actually applied, and this is where the state of the machine is right now. And the only way to know that is you need to know what all things were executed on this particular machine. So knowing the desired state of something is, or knowing the current state of a server is difficult. You cannot say that these are the things there unless you verify every step and check that, okay, these things are there. Otherwise, it is actually difficult to figure out. So scripting in a way, so it helped. It is better than doing it 10 times manually, but it still have issues. Okay. So people realize this over a period of time, and they also realize that it doesn't really scale. And then after this, certain tools comes in. So those are the one that we are talking about are the configuration management tools. So things like Chef, Puppet, Ansible, these are the configuration management tools that comes after the scripting. Now, in this case, what you are essentially saying is you are not worrying about the current state of the machine. You are saying that this is my desired state. This is how the machine should look like. And then the way you define that desired state is in a declarative way. You say that these are the things I need in my machine. Okay, this is what it should look like. And I don't care how do you get there. Okay. So it is up to the tool to figure out how to actually get to the desired state. So I don't need to now worry about the current state at all. Okay, the tools will figure out that if this is not there, I need to do this. Do I need to skip some step? Do I need to carry some step? All those things is part of the tools implementation, and I don't need to carry those things out. Then the code, because it is declarative, it is easier to understand the state of the machine. Okay, what all things are there. So you basically can just uh, read through the code, and you know that this is what the machine essentially looks like. Okay, and these tools actually become quite successful, quite famous, and they essentially are being they got adopted a lot. Okay, around this. If you know that Chef Puppet is more like a client server architecture tool, Ansible is something that doesn't have it, so it's an agentless implementation. Okay, so Ansible doesn't need a agent on the machine. In case of clients, Chef and Puppet, you need an agent on the machine, and then you need a server as well, which essentially pushes the changes uh, to those machines. So it knows that these are the machines where the agents are running, and it communicates with the agent and sends the desired state. Okay, so those are the things, those are the configuration tools, and we will see that how they actually changed. So earlier when they were created, they were like great tools. Okay, but after the context has changed, we will see that how they are essentially need to change in terms of, so most of the tools have added uh, more basically features as to address those gaps. Okay, but those gaps were real, so we need to understand what those were. Okay. Okay, so it works great. All these tools were used, but there are still some challenges around this. One is the configuration drift is still there. The nature of the hardware was fixed. So you have like 10 servers and those are not going anywhere. Those are there, those physical machines sitting there. And then what you are doing is all you are doing is the configuration management. All you are doing is to change those state of those machines. So even if you are carrying a deployment of your application, you are essentially saying that I need to go to this machine, or you use a tool, that tool goes to the machine and then says that now instead of version 1.2 running on that of the application running on that machine, you change it to, let's say, 1.3 or something. So you changed the artifact in some way on that machine, but this machine is same. You reconfigure the same machine again and again to essentially change or perform the deployments. Okay, so over a period of time, what happens is the machine actually accumulates changes that are done through the automation, as well as it will also accumulate changes that are done possibly manually as well. Okay, and because of that, what happens is you don't really know whether if you have the automation, whether that automation is completely in sync with the actual thing or not, because people have performed the manual changes there, and the physical machine doesn't go away, it is already there, it is always there. Okay, so automation and the gaps between these two essentially are the problem because of the manual changes or any other kind of changes due to this. Okay, so so in this case, what happens is, so if let's say automation is executed, it fails for some reason on, let's say, UAT or something, and you quickly realize while debugging that this is the missing thing. But you don't have time, you need to get the services up and running. So what you did is you did a manual fix, and you said that we will do, or somebody does a manual fix, and they basically say that we will update the automation later. So if you do a manual fix there, what has happened is it's not part of the automation, at least right now. If you do it, if you go and do it, that's great. But if you miss that, or you do it in a different way in automation, so all those things are a problem. Okay. So there's a possibility that now if it is running in, let's say, UAT environment, it is a mix of because of the automation as well as because of the manual change. Okay. You don't know what is the reason that application is now running. Is it because of the manual change that you did, or is it because of the automation? Okay. Now, if you run that same automation, let's say in production, at that time it fails because it probably have that change, but it is done in a different way, or probably it doesn't even have that change. Okay. So that's a gap. And now if goes and blows up in production, and that's where you lose the confidence on that automation. Okay. And that is probably when you get like afraid to run that automation. And if you get afraid to run that automation, you essentially more and more things get accumulated manually. Okay. And then you gap between the automation or infrastructure code and the actual infrastructure actually widens, and that's where the issue just comes in. So you are then essentially just keeping things running manually. That becomes a problem. Okay. Now because of the mixture of things on the physical machines, things that are performed through the tooling, through the automation, and things that are probably done manually. It is, if you need to create a same machine, let's say, so you buy a new machine, you need to say that this machine should have the same configuration as some other machine, then it might be difficult to actually reproduce the exact same machine state through the automation, because you don't really know what are the gaps in that case. Okay, so that's a challenge. That's where those were the challenges, but it was still the fact that these tools were like quite popular and they were really useful for that time. Okay. Then more things happened around the technologies, and people started moving away from the physical machines. Okay, so you basically have things like virtualization, and you can define software. You can define the networking through the software interfaces. So what you essentially end up doing is you end up with a virtual, uh, basically the VMs rather than physical machines. So even if your infrastructure is like 4 or 5 machines, you can simulate more machines than what infrastructure you have. And that allows you to do like isolation of these applications, and at the same time, the same infrastructure is being used in a so utilization is basically better in terms of a virtualized environment. This also leads to the creation of clouds. Okay. So that's where the clouds come in, and the cloud essentially changed the whole game. Okay, we'll see that how that affects the practices before the cloud. Okay, so cloud
Prashant,
changed the game. Yeah.
Yeah, sorry. I'm just saying, do you want to take questions now, or do you want everything to be at the end?
Anything is fine. Are there any questions?
Yeah, there's one from Rohit Singh. Rohit, do you want to go ahead?
So on like for the scripting thing, we have some limitations. So there were 3 or 4 bullet points, but aren't they all related to each other? So basically, previous.
So they are kind of related to each other. Yes. Which one are you talking about? This one, right?
No, sorry. Like next, the where we talked about chef and puppet. So
That is not necessarily scripting, but yeah, this one.
yeah.
Yes.
So these are like all are related. All are like a single point.
Yes, yes. The thing is, you have like static machine or static fixed hardware. Okay, if you have that, then it will accumulate changes because of multiple things. Okay, on a same machine, even if so, manual change is one kind of drift. Another kind of drift is a different automation scripts runs and changes the servers in different ways. Okay, so there are other ways to it's anything that mutates, okay, the machine state in a inconsistent way is basically taking it away from the automation, and that's where the issues comes in. Okay, so yes, there these issues are related to each other. Okay.
And I had
But
one.
somehow, so for example, you cannot, it is difficult to produce something from a scratch. Okay, and the reason is you are not doing that every now and then. There is no new machine that is there sitting that you are essentially creating again and again. Okay, so you are not essentially practicing it. So when you do have a new physical machine, at that time you realize that okay, there are gaps in the automation, and then I'm not able to essentially say that this machine is exactly same as the other one. Okay, so that's a side effect of the same thing. Okay, configuration tip. So main concept is the configuration tip. Okay, does that make sense?
Yeah.
I had a question regarding the scripting bit. In scripting, you had idempotent steps, right?
Yes.
Yeah. So what if so in this basically you said if you want to install a specific version of a software, let's say Java, then it will check whether it is installed or not. If it is
Yes.
installed, then it will skip it. What if
Yes.
what if let's say we want to install a specific version of Java, let's say we want to install Java 11 and Java 8 is pre-installed there. So will it remove the first?
It will not.
No?
Depending on your check again.
Okay.
Those are the issues. Okay, so
Hmm.
that's why we say that we don't want to deal with this. We
Hmm.
should have tools that do it for you. And the thing is, tools are also standardizing these practices. Okay, you are solving the same thing, somebody else is solving exactly the same thing, and then you realize that the entire industry is essentially solving the same thing, and then that's where somebody says that okay, we need a tool that does it for you. Okay, so that's the gap essentially. You say that I need this particular version, and then you check for the version or you check for the Java is your implementation detail. If you say I check for the Java, then I remove everything or reinstall or just basically skip this step altogether. But then there are issues now. Okay, so those are the things. Do you undo? Do you not undo? Those are again the implementation details. Okay.
Yeah, I think just to add also, I think that's a good point. I think I also, it really boils down to what the essence of declarativeness, right? So I think it kind of
Yes.
suggests that uh, if I want a state to be reconciled to a particular version, and that is kind of makes it very opinionated. So when I say that I want version 5, it means the module that is going to handle perhaps is going to uninstall if older versions are installed and then restored back into 5. So, but that is something is completely abstracted out for a guy who's declaratively saying this is what I want.
Yes, yes. So even if you do this kind of implementation, okay, looking at a script, it is very difficult to know what is there and what is not there. Okay, and you also need to know this history of things. Okay, and that's where the issues comes in. But if you have a like declarative state that I don't care the current state, I just need this is my destination, and you just say that this is the destination. I don't care what is your current state is. Then you are not thinking in terms of how to actually get there, but you are saying you are just specifying that this is where I want to be. And then that becomes easier to even understand what is the state of the infrastructure is. Okay. So if I move to the cloud, okay. Now
And just
cloud
one more
essential.
point I've also seen is basically when we say about declarative, it also means that do you want to uninstall the older stuff, whereas like point the new stuff. I basically want to just make sure that the new stuff that is being installed is being used by making you point it to the newer stuff without deleting the older stuff. So whether you want to prune it or not, I think that is also kind of an option that is given in declarative.
Yes, and that is again dependent on the tool.
Right.
So for example, in case of things that are stateless. So in case of Ansible, let's take an example of an Ansible. If I have a, if you actually have used Ansible, you say that I need this particular, I need, let's say, Java of this version present. Okay, that's what you essentially say. And then when you execute it, it will be looking at the state and say that, okay, Java is not there, I will do the installation. Okay, now if you say that I don't want Java anymore, okay, so you cannot just say that I will remove this code. What you need to say is, you need to say that I want Java this to be absent to start with. Once you have to say absent, then you apply it, it basically removes. And then next time, then you can remove that code. Okay. That is because the implementation of Ansible, and they make it clear, because Ansible doesn't have a state. Okay. It doesn't maintain the state. So it cannot figure out that what was the previous code and what is the new code. Okay. So it only looks at, this is the code and I need to perform these actions. And it also checks that, do I need to perform this action or not? So you have to be cognizant enough to essentially produce that. But if you take an example of something like a stateful thing, like a, so we are going to talk about that, like a Terraform. So Terraform, if I remove a code, Terraform will understand that you remove something, because it also maintains a state. Okay, so again, there are tools that have handled this in different ways. You need to be aware of which tool you are using and how it actually works. Okay, just to extend on that.
But Prashant, it must be doing some kind of like dependency management there, no? So like suppose I am saying that I don't want this particular library. Okay. So then like if some other package is using that, then like it would like Ansible must be doing that at least. So it would be saying, huh?
That again depends on the implementation of module. See, these tools that are created, they are extensible. Okay, that means they have a core execution engine, and then there are set of modules that are created. Now that module implementation need to choose that how they are essentially solving it. So in this case, I am assuming that it will essentially fail. It will say that I cannot install this, and this failure is most likely is coming from the OS itself, or the way you use APT. So APT itself is saying that you cannot uninstall this because it is being used by this particular guy. Does that answer your question? So it is yes. So in a way, it will be result into a failure. So you have to go and fix it. You have to understand why it is actually saying that I cannot do this.
Okay.
Okay. Okay. So let's move to the cloud. So in this case, we essentially moved from a static set of servers to completely dynamic infrastructure. Okay. Everything is on demand. Nothing is pre-created. Nothing is there. When you say that I want to move to cloud, nothing is given to you. Okay. It's all on demand, and it's all provisioned by you. No, don't need to, let's say, call AWS and say that, okay, I need 4 servers, please create 4 servers for me. It's nothing like that. Okay, so if you see, it's like basically the self-service model. You serve yourself, and everything is API based. So even if you are using AWS CLI, we're essentially calling the APIs, the REST APIs, that in turns are carrying out the provisioning of machines and everything for you. So, and when you provision those, it's not like it's taking like 2 hours to do that. It is on demand, and it is within minutes that it happens. Okay, so basically that's why you don't need to pre-order something. You don't need to have servers running, just sitting there, just in case you need it. It's not required. Okay, so it will be basically you can do on demand infrastructure. The thing is, once you do that, okay, once you say that now my infrastructure is on demand and I can ask for the infrastructure any point of time and it will be given to me, then there is nothing there. Okay, and things can come and go. Okay, they doesn't exist forever. They will come, essentially you use them, they might actually go away. Okay, so that's where the dynamic infrastructure essentially comes in. So now you don't really know anything, what is running where. You don't really know anything. Okay. And that's where so one service that was running on one instance, let's say this was the IP address of that. And if you remove that machine and recreated it recreated it again after a while to install or to run that service again, now this time the IP address is completely different. Okay, so things are now completely dynamic, they are moving around. So now you need so you cannot just rely that, okay, this is the IP address of something, I just call this and that's it, I am done. That's not the case anymore. So you need a way to do a service discovery. You need a way to do something around this. Okay. You cannot just rely on a static configuration. I know that these are the services, these are the machines, and this is where things are. It's not anymore. Okay. So you need a service discovery. You need things like private DNS. You need things like load balancers, which essentially allows you to send it to the machine. So even if the machines themselves are going away and coming back, the load balancer keeps track of what need to be uh, uh, getting served under that load balancer. So all those things are there. So the dynamic things are introduced now, and then you have to deal with it. Okay. Then it's not only dynamic, to be honest. So cloud is not only dynamic, it is also elastic. What do I mean by that is, so if I'm doing certain provisioning, if I'm saying that give me certain machines, okay, those machines will be created for you on demand. Okay, but demand is being done by you. Someone is doing that, or someone basically writing a script or running a job or something. Okay, in which the provisioning is happening. But now, because everything can be provisioned through the code, that means it can happen on the basis of some other things like auto scaling. So if the load of these services are like huge, then you are adding more machines at runtime. Nobody is there. Okay, nobody is manually doing it. It is being added because of the load on that machine. So it can happen at 2 a.m. in the morning, and nobody is actually looking at and managing that infrastructure. It's all automatically happening. But then once those machines actually comes in, okay, they need to have the right configuration, they need to have the application installed, they need to, so if my server uh, uh, if there is an application that is running, let's say 1.2 version is running, then the new machines that are added to handle more load need to have 1.2 running there. Okay, so all those things has to be there. That's where the elastic nature of the cloud comes in. And things are, because it is elastic, you can increase or you can scale out, and you can also scale in. So things can actually be thrown away. So that's where the disposable infrastructure comes in. Okay, you basically just get rid of things. That's where you also save the cost. Okay, you don't need to pay for things that you are not even using. So that's where you want to actually do that, so that you can reduce the cost. Okay, so that's why I say that the cloud has changed the game, and now let's see the effect of that on the tools. Okay, so now if you see the configuration management, so earlier only configuration management is what we were doing. Okay, because the infrastructure was already there, it was all set, it's all there. Okay, physically. Now what you are doing is pre cloud. It is you who was configuring the machine. So you, any change you need to do, either you are doing through pipelines or some other ways, scripting, any tool or anything, you are saying that I need to make this change to this set of servers, and you are performing that. And the configuration tool, let it be Safe, Puppet, Ansible, whatever, it basically runs, it goes to those machines, it makes those changes for you, and that's what is happening pre-cloud. And the inventory is static. So inventory is a term that comes from Ansible, and inventory is nothing but just set of machines or set of hosts. Okay, so that was static. So I know that there are 4 machines, these are the IP addresses of those machines, and it's not going to change because those are physically sitting there. Okay, but in case of cloud, now we have like different ways to do the configuration. Because it's a VM, I can essentially create a machine image like a AMI or something. So that means if I need to create AMI, a pre-baked AMI, which has everything installed. So Java is installed, or OS is configured, or whatever else you need as part of that, it's all installed, and AMI is created. That means I am now doing configuration management at build time. Okay, I'm building an AMI. At that time, I am doing the installation of the of all these things. So configuration management is now happening at build time. It can also happen at deploy time. So when I'm actually adding a server or creating a server, or let's say set of fixed servers are there. So I'm, even if I'm on cloud, I can actually use the cloud as a fixed set of servers. Okay. It might come and bite you because Amazon doesn't guarantee you that your servers or machines will be running forever. Okay. They might actually fail, and then you have to replace them. Once you replace them, your automation will not work, because once you replace them, the newer machines will are essentially having different configuration, different connectivity, different IP addresses. So now you need to go into your automation and make and do the changes. So in case of Ansible, if you are maintaining a static set of IP addresses, and the one of the machine fails for whatever reason, and you need to create a new one, you end up with a new IP. So you need to go and change the configuration to use that new IP everywhere. And if your applications are also relying on IP addresses, so they are essentially calling a IP address, then you need to change all the application configurations as well. Okay, so that's why I'm saying that don't treat cloud as dynamic infrastructure. Don't treat it as a static infrastructure. Okay. Try not to think it as a fixed set of machines. It's not. It can actually change. Okay. So in this case, in case of the deploy time, you can use Ansible, but now see that Ansible has a limitation because Ansible doesn't have a agent running on the machines. In case of Chef and Puppet, actually, there is an agent running. Okay. So in a way, if you have, if you bake that agent as a part of the AMI, and if you create a new image, a new instance from that AMI, the agent can actually go back and register itself against the server. So in a way, Chef and Puppet actually have much more dynamic inventory, or much more dynamic discovery of the infrastructure. If a new instance comes in and the agent registers or tells it to the server, then Chef and Puppet knows that there is new machine that is created that I need to configure. Okay. But Ansible, because it doesn't have an agent, it is up to you that you need to figure out how do I, so if a new machine is created, it need to be configured, it need to be added in your inventory to be able to do that. Okay. So that means doing, so you can do, of course, there are features added and everything, but now think about the auto scaling events. If a load increases and then you are adding more nodes or more machines at runtime, and nobody is there, there's no deployment happening, nothing is happening. Okay, but the because of the load is increased, let's say CPU is increased or something like that, and you want to auto scale things, then you are adding more instances. Those new instances need to have everything configured. So either you do it like if you bake everything in the AMI, it's all there. Okay. But if you want to do a configuration at runtime, you can do that. So Chef and Puppet essentially can figure out that there is a new instance created, and then they send the configuration to be installed. Nobody does it because it takes time. Okay, the whole point of creating a new instance is because we want to handle the load. So configuration at runtime is kind of avoided. You try to do it in the AMI as much as possible. But what I'm trying to say here is because of the dynamic nature, Chef Puppet can possibly do that because of the registration mechanism. But for Ansible, you need to have some other mechanism. Either you use something like Ansible Gate, and you run it as part of the instance own lifecycle. Okay, so once instance comes in, something like a script that runs at the startup of the instance, and that script essentially connects or calls the Ansible and fetches the right playbooks to run, and then configure the machine. So doing running Ansible at runtime during the scale up event is essentially hard. So that's what I'm saying. The context changes, your tools actually usage of the tools changes. Ansible has something called as a Ansible tower that does and supports this, but an Ansible tower is something that is paid. Okay, so all those things comes in. The inventory is dynamic, means the machines or set of machines are continuously changing. Okay. Now, in this case, so configuration management is great. We talked about it and we understand, but there is something completely new now. Okay, which was not there before, which was like infrastructure provisioning. Okay, the machines were already there pre-cloud. You basically had those machines which you can configure again and again. But now there are no machines because machines are required to be created and destroyed because it is possible. Okay. So now you need to think about, or you need to solve the infrastructure provision. There is no infrastructure. You need to be creating those infrastructure. Once the infrastructure is there, then you can do configuration management. Then these tools will actually go and install and configure and do everything. But infrastructure also need to be created first. Okay, so that's where the infrastructure provisioning comes in. So that's where the tools like Terraform or CloudFormation and others essentially comes in. So they solve the infrastructure provisioning problem. They essentially say that I need these many instances, these many machines, I need this auto scaling group, I need this load balancer, I need this Route 53, everything you essentially create as part of these tools. Things like Ansible actually added those modules. Okay, so it is now like a hybrid tool. It can also do provisioning for you. Okay, but its core was to do the configuration management. Okay, now instance lifecycle management becomes a thing. Okay, earlier you don't need to do lifecycle management of the instance because it was always running. It was always running. But now because instance goes away, comes back, and all this thing, you need to think that do I need to do anything at the startup of the instance? So that's where the runtime configuration comes in. Or do I need to do something when it goes away? Okay, do I need to gracefully turn off the services that are running and handle the traffic accordingly before it gets scaled? So all those things comes in. So instance management or lifecycle management of the instance will essentially comes in. Okay, so once you have this, you end up with so people realize that earlier we used to do like fixed set of machines and we configure them again and again. But now, because things are going and coming in, we have an option of something completely new thing, which is called as immutable infrastructure. So as you have like immutable object in a programming language, for example, in Java you have like string, or in functional languages you have like everything immutable. So what you essentially do there, if I change this string, if I say append something or if I say substring of a string, okay, what I do or what I get is I get a completely new object. Okay, the earlier object is not changed. Okay, if I don't hold the reference to that earlier object, it's just garbage collected. Okay, so I can do a substring on a string, but I end up with a completely new object. I don't really the substring is not really changing the original object. The original object is, if it is still being used, it will be there. If it is nobody is using it, garbage collection will happen and that object will be destroyed. The same thing can be applied to the infrastructure. When you say immutable infrastructure, what you are essentially doing is any change to the infrastructure is only done by replacement, not by in place changes. Okay, so when you make a change, you end up with a new object, or you end up with a new instance or new thing of that, and then the old one is destroyed. Okay, so you never change the old one in place, you destroy that and you create a new one. So then you can do essentially the immutable infrastructure. And in this case, majority of time you will do configuration at the build time. You have the AMI. But sometimes, so it's always a balance. It's always a combination of things. Okay, you probably, if you do everything, like everything at AMI level, then for a very small change also you need a new AMI. Okay, you can do it obviously, but you need it. Okay, every time. If you choose to do like almost everything at the build time, but just certain things are left out at runtime, that also works. Okay, but what you're essentially saying is you are saying that I am not changing any existing instances. I am creating a new instance, a completely new one, and then getting rid of the old one. That's what you are doing in a immutable infrastructure. So you essentially can do a AMI based build time thing. You can do a configuration at runtime, certain configuration at runtime, but this is happening for newer instances, not the old one. You change by replacing the servers instead of updating them. Okay. This helps you to reduce the configuration drift. Okay, so if somebody has made any manual changes to the old machine, that machine is now removed completely, and the new one is created. And the new one is created through automation. Nobody is creating it manually. Because the new one is created through automation, it doesn't have that change which was done manually. So you throw away that, and you have the brand new copy of the same thing. Okay, so it helps you to reduce the configuration drift. Okay, so that's why you essentially say that. So I like this quote. Okay, this appearing servers is a feature, not a bug. Okay, and this is about the immutable infrastructure. So and this comes from the infrastructure as code book. Okay, at least the edition 1. I didn't see that in the edition 2 for whatever reason. And the story is something like that. You have installed let's say some server, FFT server or something, and that server is installed on the machine manually by someone, and people started using that server. But once you do a deployment, or you basically recreate the infrastructure, you do it by removing the things and recreating a fresh one. And once you do that, that server is no more because it's created manually. So there is no FTP server running anywhere now. And that is not really a bug. That's a feature of the way you are doing the things. That's where the immutable infrastructure comes in. Okay. Now, the next disruption that is now happening is the Kubernetes, essentially, the orchestration platform. Now everything is becoming or moving towards the containers. This is like highly dynamic, uh, even more dynamic than the cloud, because it's very easy to actually do things like creation of a pod and getting rid of a pod and all that, pod or a container. It is completely immutable. So you don't even think that you will go inside a Docker image and then we'll change the binary, or we change the jar or var or something like that. You don't think like that. In a EC2 instance, you will do that. But in a Docker image, you will never do that. You will basically you will remove the old Docker image and you replace it with the new one. So it's like performing the immutable infrastructure. Okay, build time configuration management is what you are doing. So Docker files is basically like a AMI. AMI is creating a machine image. Docker files are allowing you to create a container image. So you are saying that this is what I need in my thing. So you're doing the configuration at build time when you are building that image. Most of the deployments are now getting standardized because almost everyone is trying to use the same tools because of the Kubernetes. It's not like that there are like tens or different orchestration platform that people are using. Almost everyone is now, when you say container orchestration, you are essentially talking about Kubernetes. Okay. So that helps in terms of tooling and everything. Everything is kind of getting standardized, like public. So Helm charts is there. Almost everything that you want to install on a Kubernetes cluster, you just say Helm install Postgre, or helm install whatever Nginx, helm install Prometheus or something like that. And it becomes so easy to essentially do that. Because the platform is known, it's standardized, people can create tools on top of that, and then it allows you to use those tools. Now things are moving completely on Kubernetes based, like things like operators. Okay, so even if you have you need to still create crowd based things. Like if I need to create a S3, I cannot create it in a Kubernetes cluster. Or if I need to create a Route 53 entry, I have to create it in AWS. Okay. But now what people are essentially doing is they are saying that I will create an operator or a custom resource. Okay, in Kubernetes, which will in turn manage the cloud communication. It will actually create it in the cloud. Okay, but I will not deal with that. I will essentially create a YAML file that is created in a Kubernetes cluster, which in turn is creating the infrastructure for you. So that's where the operators are coming in. There are lots of things. Even there are things like Terraform operators and things like that. So if you see the Terraform operator, it is provided by HashiCorp. And then now instead of writing Terraform code as a Terraform thing, you are essentially writing is as if it's a YAML in Kubernetes, like a pod or a deployment. Like that, you are writing the Terraform resources, and then once you do that, so this is the example of a what is this workspace. Okay, and then you create all that, and you don't need to deal with two different tools now. So half of the infrastructure is created through Terraform, and other half is created through something like Helm or YAMLs. You don't need to do that. You can actually do it, extend the Kubernetes to essentially do this for you. And there are other tools. There are other tools as well. Okay, around this. Then there is something that is coming up like open application model. Again, this is Kubernetes based, in which people are saying that instead of talking about low level things like infrastructure, like I need a deployment, I need a pod, I need a service, I need an ingress, all those things, instead of talking about low level things like which objects I need in Kubernetes, you don't talk about that. Okay, you talk about high level things like I need an application. This is how my application looks like. And once you talk about that, it's the tool that will take care of how to create those things. And all these things are done through operators and custom resources. So I can give you an example of that. So if you see, so this is the open model specification, which is the kubela is an implementation of it. There are other tools as well. This is only one of them. Okay, so if you actually see the way they are defining, they're essentially saying that you define an application. So like you are defining a deployment or a pod on Kubernetes, you are actually defining an application. And here you are saying that that application consists of components. One of the component is a web service. And this is the image of that web service. And this is where the port runs. And I need an ingress. So you essentially said everything that for this, you need like multiple different YAMLs just to specify this in Kubernetes. But now you're saying it at one place, and you can also give like more dependencies on that. So it's one need not be only one component. It can be more component, more set of components. Okay, so they are supporting Kubernetes, they are supporting Terraform, they are supporting Helm components, all this. So that's where the things are moving now. Okay, and you need to be aware of why things are moving there and why the new tools are being created. So that's where the context comes in. Okay, so that concludes the evolution of things. Are there any questions?
There's nothing in the chat. Does anyone want to ask something directly?
Okay, if there is
I guess
nothing,
not. Yeah.
we can move to the next set of things. Okay.
All
So now we actually talk about the infrastructure as code. We understood the tools to some extent. We understood the nature of the infrastructure, how the how the practices changed, how the things actually evolved. Now let's talk about the infrastructure as code, and what I have seen majority of time people get it wrong. Okay, so we say that almost everyone of us understands when we talk about infrastructure code that we specify the state of the infrastructure as code. So almost everything is essentially code. So your infrastructure is code, your configurations is code, your pipelines are code, even the policies and etc. All of them are code, and it makes sense. People do understand this. Okay, and all code is in version control. So you essentially put it in Git and apply the same practices that you apply for a application code. Okay, and because you put it into a version control, you essentially can see every change. You can track every change, who made what change, why it was made, and how the code actually evolved over a period of time. And you can also go back and go to a previous state of the things. Okay, but I have still seen that people actually get things right on an application side, but get it wrong on the infra side. Okay, and I will give you an example of some of those. So if you see the way we deal with the code and the configuration of anything, most of us are now aware of what the 12-factor app is. And in case of 12-factor app, there are certain things, guidelines for the code and the configuration of the application. Okay, so this talks about application, but what I'm trying to say here is it also is applicable in terms of the infrastructure code as well. You get the same set of, if you follow the same set of practices, you get the benefits of that. Okay, so what the 12 app actually talks about in terms of a code base and in terms of the configuration. So if you talk about the code, let's talk about the code first. What you are essentially saying is the same code, it is tracked in a version control. Okay, and the same code is getting deployed into multiple environments. Okay, now when you say that same code is getting deployed into multiple environments, it's not exactly the same code that is going. A version of that code is actually going. Okay, what do I mean by that is production might be running an older version than what is running in staging, or than what is running in development environment. Okay, but it is still, those versions are still created from exactly the same code base. It is not like a different code. Okay, version in this case is just a snapshot in a time. Okay, in the past, just a snapshot of the code in past. Okay, it's not a different code. Okay, so that's where the version is. Okay, that's how we are doing it, and we are all doing it for the applications. It's not a new thing. Okay, so this is one thing. And then there is something called as a configuration. Okay, now if you see the 12-factor app, configuration is something that is kept outside of the code. It is not part of the artifact. It's not part of the jar. It's not part of the build or artifact that you create. Okay, then how do you actually create and deploy something? How do you create a release that you want to deploy in an environment? So how do you do that? You essentially say that this is my build and this is my config of this environment. I mix that together, and that's what constitutes a release. Okay, that's what constitutes a release. That's what you're deploying in the end. So you have so if you are like using something like a Spring application, you have a jar or you have a Docker image or something like that, which is the build, and then you have a application configuration file, so app config file for that particular environment. Okay, and then you marry them together, and that becomes the deployable that you want to deploy in an environment. Okay, that's what you're essentially doing. So to actually simplify and to put it in perspective, you can think it like this. This is what is happening. So you have, and you apply it for the infrastructure as well. That's what I'm trying to say here. So you have an infrastructure code, and there are versions of those infrastructure code created. As I said, the version is just a snapshot in time. Okay, it's not a different code. This is basically a snapshot in time. Okay, and then that a particular version is used, and it is combined with the configuration of that environment to essentially generate a release for that environment. Okay, so in this case, we are saying that the version v3 is combined with the dev configuration to generate a dev environment, or version v2 is combined with production configuration to generate a production environment, production release. Okay, so that's what you are essentially doing. That's how you are generating a specific release or specific deployable. Okay, so it's a standard practice in terms of application code. Okay, but I have seen that majority of time people get it wrong in the infra code for whatever reason. People think that almost everything in infra is config, and it's specific to an environment, which is not really the case. Okay, and then that leads to all kinds of problems like duplications. That leads to problems like not having standard environments. Your environments looks completely different, so all those things happen. So let's look at some. So this is the summary of what we talked about. We said that code is same for all the environments. Okay, there is a single code, it's not separate. Configuration is different per environment. Every environment has different configuration. Okay, you basically have different configuration. Then code has a version, and you deploy a particular version in an environment. There is no versioning required for a configuration. Configuration is always latest, but it is tied to an environment. So in case of configuration, you are actually making duplicates. Every environment has different configuration. Okay, they need to be same in terms of the thing, but physically they are different copies. Okay, and that's what you are doing, and you always use the latest. There is no versioning required for the configuration. Now in this case, most of the time you will have overridable defaults. So application uh, might have some configuration code, the build or artifact which you created might have some configuration code which you can, which basically gives you a defaults, and then you have to override them for an environment. Okay, so that is possible. Okay, but certain things doesn't even have a default value, like URL to, let's say, database doesn't have a default value. You need to know that what is the URL of the database in dev environment, which is completely different. What is the default in that case? Okay, then you need to have a different database in production, and that URL will be different. So you essentially need to have different configuration for different environments. Okay, sometimes you will have defaults. So like thread pool size is probably will have like 100 threads in my thread pool is a default value that you might not need to override in a dev environment. You might need to override it in a production environment. So in this case, it becomes an overridable default. Okay. So that's where it is. The configuration is separate per environment, but the code is same, and a version of a code is used. So this allows you to do things like if you need to perform a change. So let's say I'm running something on production, and I'm right now running 3 instances in production. Okay, and instead of 3 instances, I want to change it to 5 instances. Okay, now if I want to do this change, it shouldn't I need not release a new version of the code. Okay, my code that is running is still exactly the same. It should be same. Okay, all I need to do is change from 3 to 5. Okay, and you think that is it possible in your case? If you need to do a code change and release a new version, then your configuration is not sitting outside of the code. Okay, it is coupled with the code, and because it is part of the artifact or whichever code that you are maintaining, that's why you have to do this. Okay, so that's where the things comes in. If you keep it outside and then all you need to do is change the production configuration, the code is exactly same. All you are saying is instead of 3, run 5, and then you apply that. You essentially change that thing. Now also see that you are using a version of the code, not the exact code. Okay, that means even if somebody has changed the code in the meantime, that doesn't affect you because you are not using the latest code. You are using a version of a code. Okay, so that's where the things comes in. That's where you should be able to perform these things. Okay, so if I move to the next thing, so let's look at some violations that actually violates this thing. Okay, and unless you check, so you might be thinking that, oh, we actually understand this and we do this, but I have seen people actually violating it and do not realizing that they are actually violating this basic things. So if I go to one of the violation, so in this case, I have like environment specific code. Okay, environment specific branches, or so it can be a folder, it can be branches. I have seen it in terms of branches, so that's why I've shown it in terms of branches. So in this case, you are saying that my dev environment essentially have the code and the config. So it might be Terraform code, it might be Helm charts, it might be whatever. Okay, but it is there and it has everything. So entire Helm chart is there for that dev service. So if I have like 5 services, there might be 5 Helm charts, there might be one Helm chart deploying all 5 of them, but it is for the dev environment. Okay, then you have a separate one for UAT, then you have a separate one for production. Now in this case, if I need to make a change, so 5 is like modest value, but if you are like 15 services or even more than that or even less than that, if you need to make a change in all of those, you have to do like 15 services, you have to change at first 15 places depending on how you are managing that code, and then you have to do that 3 times per environment. So you will like duplicate almost everything. But what you are essentially said here is the entire Helm chart or entire Terraform code is a configuration because it is specific to an environment. But that is not the case. Okay, there is element of code that can be standardized, that is a code, and then there is a configuration. Okay, so certain things are configuration, certain things are code. You want to separate that out. Ideally, the code should be only mentioned once, and that way you avoid the duplication. And you also make sure in this case, because in this case, what happens is your dev essentially can look completely different than your UAT or production. Okay, it potentially can, and if you want to keep them say in sync, it is like a tremendous effort on your side. You have to keep that in sync. Okay, so this is one possible violation that you can see. Then there is another violation is you do realize that that you are actually duplicating a lot of code in here. Okay, then you say that, okay, I will have like a shared code, which might be a module or which might be something. So Terraform module is there, or it might be Helm chart or something like that. And then all this, the environment specific things is essentially just using the same code. What is the issue here? So you are not having duplicates. So what is the issue here? I am assuming, yeah, what is the issue, possible issue here? So there is the issue, what could be, I'm highlighting here. Any guesses? So what is the issue is, if you are using the same code, okay, and not the version or the snapshot of the code. Basically, you are not using a version in different environment. If I make a change in the shared code, that is visible to almost everything. So if I make a change in that code, in the shared code, it is visible to production as well. Okay, so if I need to make a production change that I said from 3 to 5 instances, if I do that at that time, the new code, if somebody is working on the changes to the infrastructure code, those will be visible during that time, because I am not using a snapshot in time. I'm not using a version. I'm using exactly the same code. Okay, that's where the issue also comes in. So you need to also have versions in place. So I have seen this as well. I have seen people having Terraform modules that are referred through paths. Okay, but it's not using version at all. Okay, so
So,
what could
sorry.
be a non-violation?
Prashant, I
what?
just have one question. So on
Yeah.
previous slide, when we say version, we can have, use tags as a version, right? It's not necessary we
Yes,
need to
I
do
am
any
going to talk
artifact.
about that. Yes,
Okay.
yes,
Okay.
you can.
Okay.
Okay, so non-versions is something like, uh, so your tool can essentially support a versioning strategy for you. Okay, so Terraform modules have a versioning support. Helm has versioning support. And there are other things that also might have versioning support, whichever you are using. So tool itself gives you, so if depending on which tool you are using, it might actually give you an ability to actually version something. So in case of Terraform, you can actually use a Terraform registry, or you can even use Git tags to create a version. In case of Helm, you have a Helm registry in which if you put in the chart, it can have a version. Okay, and then all you are doing is you are referring to that version in the module, and then you are combining it with the environment specific configuration and then deploy that. So this is one possible way of doing it. You can also use Git tags in case of things like Terraform and things like that. Then the another way of doing that is you can also use branches for versioning. Okay, but in this case, the way you are using the branches is completely different. Okay, you are using branches here not as a long running branch. You are using a branch as a snapshot in time of the previous of the master branch. That means these branches are short-lived. They are created for a few time, and then they are recreated when you create a new release. The old one is deleted, and essentially you are creating a new snapshot of the branch. Okay. This strategy will allow you to also perform bug fixes if you want, if you need to. If your infrastructure code is like extensive, if you are doing like something like operators in Kubernetes and you are actually writing code, okay, and it's a complex code, then you probably want to do that because then you can do bug fixes here. Okay, and then because you are going to destroy that UAT branch, uh, the next time you need to create a new thing, you have to obviously merge back any bug fixes that you do. But the only thing you do in branch like UAT is the bug fixes. You are not doing anything new. Okay, and every new release that you need to create, you are creating a snapshot of master at that point of time. Okay, so it's still a version in a different way. It is still a snapshot in time. Okay, and in this case you can see that production doesn't have a branch. So essentially what you are saying here is any change that you need to promote to production is essentially going at least through UAT. Okay, that's what you are saying. So if you want like a separate branch for production, you can do that, and that directly goes to production. But I have seen that people generally at least put it in one other environment before they put it into production. So essentially that's what you are seeing here. Okay, and the configuration is coming from is basically specific to the environment. It's coming from somewhere else, so it's not uh, it is latest basically. That's what I'm trying to say. So branching can also be used, but it has to be used as a snapshot in time rather than a long running branch, which is completely living its own life and completely different than where it is created from. Okay, so that's not the case here. So now there are cases in which your tool might not even allow you to do version. It doesn't support that. Okay, so what will you do in that case? So there is always a possibility that you can use something like git tag. Okay, so in this case, COPS actually allows you to do cluster templating, but it doesn't give you an ability to do a versioning. So I cannot basically say that this is the state of the cluster, but in production, this particular version of the state of the cluster is running. Okay, at least not from a point of view of COPS. Okay, COPS doesn't give you ability to do version like Terraform gives you module versions, or Helm gives you versioning of the chart. COPS doesn't give you that. COPS gives you ability to do templating, but doesn't give you the versioning ability. So in this case, what you are essentially saying is you are checking out a particular version of this particular file. Only this file is different. It is taken from this version. The rest of the things are coming from master. Okay, only this file is coming from a tag. Okay, so you are essentially got a template from a particular tag, and rest of the things are from master. So what other you are taking from master? So when you say that toolbox template, and you are saying that this is the template and these are the values. So values in this case is the configuration, and you can see that it is taking the values of the dev environment. Okay, so this is a dev environment latest values. This is coming from master. Okay, so this is latest, but the tag is coming, the template is coming from a tag, so it is versioned. Okay, so configuration is latest, but the code is versioned. Okay, and that's what you are marrying together to essentially create the cluster state that you want to apply. So this becomes the YAML. So this is no more a template. This is a template. The placeholders are filled up by the values, and then you end up with a completely complete state of the cluster that you want to apply. Okay, that's what you are saying here. Does that make sense?
Yeah, it does.
Yeah. So just to summarize the code versus configuration thing, what we are essentially saying is use Terraform modules with versions, either through registry or through Git tags or whatever. If you are using Helm chart, use the Helm chart registry, use the versions. You can also see Git tag, you can use almost everywhere, universally. Okay. So you can always use that. Then use the, if you are using Ansibles or roles, Ansible roles, use that again with the versions. If you use something like Galaxy, okay, Ansible Galaxy, if you use a Galaxy role, it comes with a version. Okay, but then when you create your own roles, you forgot to do that. You do not do versioning, and that becomes a problem. Okay. Then any change that you do for development is also visible in the production pipeline, which is the problem. Then COPS template, you can do that versioning as I showed. You also you also might want to do versioning on the deployment scripts. So we write like smaller scripts for Jenkins or something like that. If you do that, you might also want to, if like that script is like complex enough, and any change in that script might affect the production pipeline or any other environment pipeline, then you might also want to do the versioning of that, and you use a snapshot of that deployment script in time. Okay, so this concludes the code versus configuration thing, and this I have seen people numerous times getting it wrong. So are there any questions on this? Is it clear?
So I have
What we
a
are
question
trying to
around. I have a question around what actually. How do you derive, or how do you actually decide what constitutes basically a release of an infrastructure as a code with, like when you have code and the different environments as configuration. So
Yes.
now, if you have so the infrastructure, are you saying that infrastructure as a code should be treated as version but not the configuration?
Yes, configuration is not one. So I can give you an example of Helm if you have used it. Okay, so if Helm chart is there, let's say there is a public Helm chart for something like Nginx. Okay, so Nginx Helm chart is there. What they are doing, they are essentially created a chart, and that chart has a version. So every time they make a change, they change the version of that chart. Now, when you take that chart and when you try to install that chart, what you are essentially doing is you are creating a release of that chart. Okay, you are creating a release, and that release is a particular installation of that chart. I can use the same chart and install it 10 times. Okay, every 10 things that I have now did, when I installed 10 times, I've created 10 releases of the exact same chart. Okay, and every time when I do Helm install, I can actually give a different values file. Okay, I can say that I want to install exactly this chart, but these are the configuration of that chart I want to install. And now I can install that Nginx 10 times with a 10 different configuration, okay, in the same environment. But the code or the chart is exactly the same, and I'm using exactly the same version of that chart. Does that make sense?
Yes, yes.
Yeah. So that's the release. When you are installing that, you're essentially saying the exact same chart, and then you are giving the value. So that constitutes the release.
Yeah.
Okay. Okay. So let's talk about some more things that you might or might not have faced, depending on the context, depending on size of the practice that you're doing. So if you are managing like lots of code, lots of teams, and you are part of a big organization, you might face some of this, you might not have faced some of this. Okay, but it's a good thing to know that these are the trade-offs into certain things. So let's quickly talk about that. So GitOps is something that is getting popular nowadays. Of course, there are again certain people who are now saying that they are moving away from GitOps as well. But yes, majority of us are looking at it, and it makes sense to some extent. So in this case, what we are saying is Git as a source of truth. So Git becomes the input for the infrastructure. It basically captures the entire infrastructure. So it's in a way, uh, it is same or similar to infrastructure as code, because you are capturing that, but it takes it to one level above, in a way that, so if you want to actually say that everything is in Git and Git is the input, then in a way you are saying that there is no builds that requires a parameter. Okay, so build with parameters essentially goes away, or there is no manual builds, because I will almost never trigger a manual build. I will make a change in the code that triggers that build. Okay, but I don't need to trigger a manual build. Of course, take it with a pinch of salt. It's not practical, like 100% of that. There will be situations, but it's a way of thinking. Have you captured almost everything there? So for example, in case of build with parameters, uh, you can do it for some of the parameters, but for some of the parameters you can't do it, like secrets or something, some sensitive information. So you might not want to put that in a code. So that's what I'm saying, that thinking is more important rather than actually applying it. You are consciously saying that why am I not doing this? But you still understand what people are trying to say when they essentially talk about Git as a source of truth, or code, so or the source code as a source of truth. Okay. Now the next thing in terms of the GitOps practice is you are trying to keep the infrastructure and the state of the Git in sync continuously. Okay, it's not only when someone is making a change. Okay, so you make a change and then you apply something on the infrastructure. That is not the only time when you actually make changes in the infra. You are continuously trying to see that there are any changes or any drifts between those two. So for example, if I make a change in the code and apply it, now infrastructure is updated, and then I go to the infrastructure and let's say change something manually. Okay, in an ideal scenario of a GitOps operation, it should detect that. It should basically say that, oh, there is something that has changed, and that is not as per the state of the Git. Okay. So again, in this case, there are two ways to essentially do that. You have a mechanism to completely revert the change that was done manually, or at least you have a mechanism to notify that there is some issue. Okay, so somebody can actually go and see that what has happened and how do I restore it back to the state. So that's what is happening in terms of GitOps. And in general, it's a good practice to actually do some kind of continuous or frequent update of the infrastructure to ensure that the state of the infrastructure and the state of the code is in sync, even if you are not doing GitOps. Then things like GitOps is essentially introduced or got popular because of Kubernetes. Okay, and the way Kubernetes works. So in this case, Kubernetes majority of tools that you see is based on Kubernetes. And the way Kubernetes does this is, in case of operator, they essentially do a pull rather than a push. So when you make a commit, you trigger a pipeline. Okay, that's the general way of doing things. But in case of Kubernetes and the operators, you essentially say that you make a change and somebody actually pull that change into the infrastructure. And the reason you do that is because those operators or those tools are already running as part of your Kubernetes cluster. You don't need to provide external access. They already have access to Kubernetes. So nobody need to make a change to the cluster. They make the change to the cluster themselves. Okay, and so that's a secure way of doing it, because then you are using the security models that is given by the Kubernetes itself. Okay, so that's the way GitOps is essentially being used. But as I said, in general, even if you are not like on Kubernetes or not using GitOps and all, it still makes sense to frequently add or frequently apply the configuration or the infrastructure code to the infrastructure, to just ensure that infrastructure hasn't gone out of sync with your code. Okay, because sometimes what happens is, if you say that only on change we will apply the change, then it might be like a long time, it might not get applied at all. And then if somebody has made a manual change there, it's almost never detected. Even if it's an immutable infrastructure, you are not actually replacing anything. You are not even running the pipelines or things like that. That means that manual change is still sitting there. Okay, and people start relying on it, then it is essentially needed to be there. And once then you run the automation, everything goes away, and then you lose all the work that was done. So it makes sense to essentially apply these changes frequently, so that you have the syncing of the infrastructure and the code. Now, the other things around updates and things like that is, if you are doing updates at the AMI level or at certain other things, then do it at the entry level, do it at the build time of the AMI, or do it at the first environment or things like that, and then log them up. So never say that. So for example, in a Docker, we say that never say Docker latest. Okay, so that's a very practical thing. You should never say latest, but at the same time, for a first environment or for during the build time, you should actually try to figure out what is the latest version, and should you use that version. Okay, so you can essentially use that version for the first environment and then fix it there, so that the next versions essentially use the same one, and you know that it is already tested. It's not a surprise in a later version. So it's already tested in previous versions, so you know it works. But at the same time, you're also getting the updates. Okay, so it makes sense to have some strategy around that to do it. Okay. Now the next thing I have seen is, if and especially when developers themselves are writing infrastructure code, they create modules of the infrastructure that are highly configurable. Okay, almost anything can be changed. Everything is parameterized, and I can use that to essentially configure almost everything. So that is great if that code is like a public thing. So if I'm writing a public Helm chart, or if I'm writing a public Terraform module, then I will try to have as much configurability as possible. I will parameterize almost everything so that different people can use it in different ways. Okay, but if you're if you're doing it for your own team, then you have to think that what I do allow as a different thing in different environments. Okay, so for example, if you say that my AMI is a parameter, okay, that means potentially you are saying that I can have a different AMI in, let's say, UAT, which is not even tested in dev. Okay, that's what you are essentially saying. So that means the same thing you can do in production as well. Somebody can make a change and put in a wrong AMI in production, uh, and blow up the deployment that is happening, and that's the problem. So you need to be aware that what you're doing. So even if you are using a highly configurable module that somebody has created, either within the industry, or either within your organization, or basically you're using a public module or something, then you have to wrap it in a way that it is still standardized. Certain things are locked down, and the only way to change them is to by having a new version of the code and not through the configuration. So that way you essentially control that what is allowed to be changed between environments and what is not. And that's important thing. And you need to be aware of this trade-off. Uh, when you write modules, think things that you need to keep in mind is like name collisions, create before destroy, that is about rolling deployments. Create before destroy only applies in terms of stateless applications. In a stateful applications, the rolling updates happen differently. Uh, but yes, you need to be thinking about these things when you create a reusable module. Okay, then you have to handle the shutdown gracefully. So as I said, that lifecycle management of an instance is important. Then you also, if you need to do things like dynamic environments, okay, then you really need to have a naming strategy. Okay, so if you say that I need to create a test environment on the fly, okay, it should come up, it should run the test, and it should get destroyed. And I want to reuse something like a dev environment. So same dev environment code should be used uh, for that particular environment. So in that case, you can use something like a Terraform workspaces and things like that. But then your naming need to use the name of the workspace, naming of the infrastructure need to do that. Otherwise, you will end up with name clashes. It will clash with the development environment in that case. Okay, so if I'm creating a S3 bucket, unless I have a way to essentially separate out the workspace S3 and a dev S3, I cannot create those two. Okay, or similarly any other SQS or something like that. So you need to have a naming strategy, because understand that when you are creating a module, there's always a possibility that the same module will be applied multiple times. So you cannot have a fixed names in the model. And I have seen this happening in the code, and then people essentially they need to later on change that. It might becomes difficult to do that later on. You have to, because it's already applied into infrastructure. So have these strategies in place uh, while creating the modules. The module by definition can always be applied multiple times. Like I said, if you have a Helm chart, I can install it 10 times. But if that Helm chart is creating the same deployment, I cannot essentially install it 10 times. Okay, because there is a same resource already exists. So Terraform or Kubernetes will say that this pod or this deployment already exists. I cannot create a new one. So that's a problem. Then there is a point about the output values. It will again come in the next slide, so I will talk at that time. The last thing I have, this is I think the last thing. Yeah, after that the configure. So last thing I have is around the modularity and orchestration. Okay. So modularity is something that you want. Okay, you don't want like a very big code that manages everything in an environment or even multiple environments. You don't want that. You want a small modular code base that allows you to change things independent of each other. So for example, if there is an issue in my Elasticsearch code, so if I'm creating I have a module that essentially creates the Elasticsearch cluster, and there is an issue there. It is failing for some reason. That should not stop me from making a change in let's say Postgre cluster or something somewhere else. Okay. So I should be able to perform these things independent of each other. It shouldn't couple each other. Okay. But if you manage everything together, it's all part of the same code. Because it is failing for Elasticsearch, and if I try to apply that change, it will essentially try to do the changes that I want for the Postgre, as well as it will try to do it for Elasticsearch, because Elasticsearch is out of sync. It will stop me from even performing the other changes. So this is because of the coupling between these two modules. So you need the modularity, but at the same time, you need to understand what you are losing. If you are like having modularity, what you are losing is the orchestration. So what do I mean by orchestration? When you say that I have different modules, you need to know in which order you performed the creation of those modules. Okay. So if there are any dependencies between those two, if you need to create a new environment, you need to know those dependencies. So either you do it like through some way of managing those dependencies in a document or something. So for example, if I create a instance, or if I create a let's say Postgre cluster, that Postgre cluster need to create in a subnet. Okay. But the subnet is being created by a different module. Then I need to know that which module is actually creating this exact subnet that is required by Postgre. Okay. And if that, so I have to ensure that when I provision a new Postgre cluster, I have to ensure that the subnet exists before I can provision the Postgre cluster. Okay. So there is a dependency, and there is an order in which you need to create things. So you need to be aware that if you are breaking things apart into modules, you need to know that how they really get fix themselves together to actually form an environment. Okay. Well-defined inputs and outputs for a module actually makes composable module. So if you are saying that I need input of something, so in case of Postgre cluster, you say that I need an input in terms of which subnet and all those things, and then there is a subnet module that actually gives you an output, then it becomes like a composable thing. Then you essentially say that this guy is giving me these details, which are the inputs to this particular module, and then you can somehow combine them. So even if those are two independent components, they can be applied independently of each other. They still are giving some way of some information handling between them to essentially create the composable models. So one tool or one example of this is it's done something like in TerraGrunt. So this is a TerraGrunt documentation. Okay. So TerraGrunt is a tool on top of Terraform essentially. So what they are here saying is, they are saying that there is a backend application which is a different component, front end is different, MySQL different, all these things are different. Okay. But then now you can say that you can define dependencies like this. Okay. Ideally, I would like to have versions here. Okay. But that's what they are saying. They probably also support versions. I need to check that. Okay. But they are essentially allowing you to see and specify dependencies between modules, which is not possible in pure Terraform. Okay. But this tool is allowing you to do that. So now when you say that uh, apply, okay, when you say run all and apply, then it takes care of the dependencies as well. So it basically understands that front end depends on back end for something, then back end depends on the Redis also depends on back end also depends on the MySQL, and then they all depends on the VPC. Okay. So that they understand this, and then if you say that create a front end app, then it will also end up creating almost everything if it doesn't exist. Okay, it will apply those things. If it exists, then it will not do anything there. So that allows for that tool is actually doing an orchestration for you. So you have created different module, but it because you have created a kind of a dependency graph, it understands that these are the things to be created. Otherwise, if you don't know these dependencies, then if I want to create the front end app, it will fail probably because the Redis is not there, let's say, or something is not there, and then you have to provision that. So you don't know. So this is like a small graph, but in reality, you can have like big graph. So you need to know, if you break things apart, you need to know how they actually combine together to form a particular environment. Yeah, so just the conclusion now. So what we have here is use the right tool for the right job. That's why we looked at the evolution of the tools and how the context actually changed. Certain tools that were very powerful earlier becomes awkward afterwards. Okay. Then follow the same CI/CD practices for infra code. So like code and the configuration that we talked about. We do that already for application code, and we really understand that. But when it comes to infrastructure code, somehow I have seen people missing it completely, and then you end up with duplicate code, or you end up with weird situations in which you have to make promotion of the new version just to make a change in the configurations and all the things. Then reduce the drift between the code and the infrastructure. So this is about making sure that you have some way of continuously applying the infrastructure code, or at least have a mechanism to highlight that there is a gap. Okay, so that you can do something about it. There are tools around this. So there is something called as a drift CTL, which looks at the infrastructure and the code and checks whether there is any difference in there, and then it highlights that. It can also send a notification on Slack, for example. So those are the tools that you can check. Then the last one is keep the infrastructure as code modular while managing the orchestration. So sometimes the dependency management can be as simple as you just noting it down, saying that this comes first, then this, then this, then this. If it is simple enough, small enough, that works. If it is like big enough, then you have to really think, and you might need a tool, you might need to create a tool or something like that. Yeah, that's all I had for the talk. Are there any questions?
Does anyone have a question? I do not have a question. Yeah. Does anyone else?
Was it useful? At least any feedback?
I mean, I liked it pretty much. Yeah, it was really good for me. Does anyone else have any feedback? Anything else to say?
Anything that was not known to you and it was useful, you probably can use it in your context or something like that.
Hi, Prashant, Ravi here.
Yeah.
So one question I have is, so like here we prescribe to have a to create the modules for different resources of the cloud, but like how we develop them in terms of having a tested resources, because it might be that some team is or maybe a part of the team members developing modules and somebody else is using, right? So I mean, so if you have to like draw the parallel between writing a
What will
library,
be the testing strategy? Is that
yeah.
Yeah, so generally what happens is, see, the way infrastructure generally works is it gets combined with the environments of the development, right? So Dev have environments like Dev, UAT and production, let's say. And infrastructure code generally gets combined. First time it gets combined in the Dev, then UAT. So it is sharing the same environments. But generally what you should have is you should have a sandbox or something different where the application doesn't exist. Okay. And that's where you can perform the deployments or run the code against those environments and ensure that those are tested there. So for example, certain people actually use things like create a test. So you have a test completely, people actually use a complete different account for that matter actually. So you have a test account, AWS account, where you create the infrastructure, you test it. So you write test around that, and you say that, okay, this is accessible, this is created, this is up and running, this is healthy, all those things you say, and then you completely destroy. So things like cloud nuke or tools like this are actually used for this purpose. So you destroy everything that is there in that test account. Okay. And that's how you can actually test it. So you need a separate environment which is not integrated with the devs. So you need something like a sandbox, which is completely owned by the DevOps team. There is no application code running. And then the next environment is the dev environment, where your code and the developers or the application code runs together. Okay.
Thanks, Prashant.
Anything else?
There were messages from Sagar and Jay. Very good detailed session, and other one says excellent session. And yeah, I mean, most of the practices that you talked about are being used in the project that I'm working on. However, I did not know why they are this way, because we have 3 different repositories, one for code, one for the infrastructure, and third one is basically a combination of both, where we have the module and we deploy these modules. Yeah. So I have used to wonder why it is that way. And yeah, today this session helped me a lot with knowing why it is the way it is. Yeah. All right. Thanks everyone for joining in. I'll stop the recording.
Thank you. Thanks a lot.